Welcome to Evolution in Controls, a video and podcast series from the Morrell Group. Thanks for joining us. It should be no surprise that compressed air is generally the most expensive utility in a manufacturing facility. But what is surprising is how little effort is spent in reducing leaks. Compressed air is generated on site, and any leakage requires an increase in generation capacity. You simply need a bigger compressor. And because compressed air may be viewed as a limitless utility, there's generally little motivation to limit or reduce its usage. Further, the quality of that utility can vary from installation to installation, and poor air quality will soon lead to poor machine performance and then downtime. According to a Deloitte study, unplanned maintenance cost manufacturing $50 billion each year and a 5 to 20% reduction in overall plant efficiency. The U.S. Department of Energy says that a cost-effective target for leakage reduction is only 5 to 10% of total flow. With so much money at stake and such a low reduction target, why isn't more being done? Here to talk with us today about what technology can do to help with this process is Mr. Bill Utter. Bill is the pneumatics product manager for Morrell. Bill, thank you for joining us.
Happy to be here, Tim.
So, help me understand. Everybody seems to know in plant maintenance that leaks happen and that air is an expensive utility. But what is really being done to help? Why isn't more being done to find and fix the air leaks?
I think that one of the biggest problems is just identifying where those leaks are. In a big plant, there's a lot of noise. It's hard to really pin down where some of the specific leak points are. It's just kind of an unheard, unspoken issue that people tend to ignore because they don't see specifically that those leaks are actually costing money.
No oil is on the floor, so what does it hurt?
Exactly. And if you understood that every one of those leaks was actually dollar bills, it would be a lot more apparent, and I think there'd be a sense of urgency to get those fixed.
So is the problem in finding the leaks, or is the problem in motivation to fix the leaks?
I think it's just finding them. I think finding them is difficult. Like I said, plants are loud, they're noisy, they're difficult to pinpoint, and I think if you could find out where those leaks are happening, people would quickly want to address those.
Okay, so finding leaks is a big part of the problem.
It is.
Is there technology to help us find the leaks? Why can't we use technology to do that?
Fortunately, there is. AVENTICS, Emerson makes a product. It's called their AF2. It's a flow meter and pressure sensor combined. And what it essentially does is part of the air prep system. And you put that on your air prep, and then what it will do is it will send a signal. It will monitor your pressure, monitor your flow, and if you have parameters that you've set that machine up to where it consumes a consistent amount of air, as you start exceeding those parameters, either on the low side or the high side, it can send a signal to machine control as to, I'm outside, I got a problem, fix it.
Okay, so the data could go to machine control. Can it go other places?
It could. There's actually a little router you could mount with that, a Wi-Fi based router, the IoT, Internet 2.0.
Send it to the cloud.
Send it to the cloud. Yep.
Okay.
It goes to your phone, it goes to your PDA, it goes to whatever you want to send it to say, hey, check this out, I've got a leak, I've got a problem.
Okay, so I assume that those are installed places. What do the plants do with that information? Are they tying it into the FMS?
Typically, what they're doing is they're monitoring. It's a constant flow monitoring system, and so I can set that system up as to where if I have an immediate leak, hose break, something like that, I can send a signal, go fix that. The problem is I don't know where the leak is, and so if I can identify the position of the leak, I can get to it very quickly, fix the problem.
Okay, so there's technology that can be applied to find the leaks. The data gets communicated back to machine control or to the cloud. Now the step is in replacing the leaks.
Correct. And at that point, we've got, you can replace valves, you can replace cylinders. Typically, when we see leaks, there are things like hose breaks, crimped hoses. As machines move, you've got moving parts that will tend to come undone occasionally. And if I can find out where those are, I can now replace valves, I can change cylinders, change seals, do whatever I need to do to get that leak stopped as quick as possible.
Okay. What role does AVENTICS play in this, and what role does Morrell play in this issue?
It's a good question. When we get asked for, typically what will happen is one of our OEM machine builders will be asked by their customer, in today's economy, energy savings are a big deal. What are you doing to build your machines more energy efficient? So if we can get in as an engineering partner on the front side and offer cost savings through adding components that can monitor both pressure and flow, air consumption, that lets our OEM machine builders then sell those machines and market those machines as an energy efficient product.
But who cares more, the OEM machine builder or the plant?
Both should care. The OEM machine builder has got a vested interest in selling a machine that is energy efficient. They have a reason. It's a selling feature for them against their competitors, and the plant obviously has a direct cost associated with air leakage, air consumption.
Okay, so how does a plant, because they're the ones that's actually paying the money for the lost utility, the air leaking out, what role does Morrell play in working with the plants?
We can work directly with the plant to come in and monitor their machine air consumption. We can set up a baseline for that on each machine, and then over time, as that air consumption goes up, we can set parameters on that machine to start doing preventative maintenance. As cylinders wear, as valves wear, we've got instances where people are replacing cylinders and valves on a yearly basis that don't have that have got plenty of life left in them. So if I can monitor cycle rates of my valves, of my cylinders, it gives me a much better indication of when preventative maintenance ought to be done as products have come to the end of their cycle life.
So you just made a switch. You went from talking about air that was leaking and information being communicated to the cloud. Now you're talking about products that may leak air or that may fail and cause an air leak?
All products, valves and cylinders, have a life cycle, a predictive life cycle, if you will. And so what we want to know is, when is that life cycle about to expire? Is it 2 years? Is it 50,000 cycles? Is it time? Is it cycle based? I'd like to know ahead of time when that product is coming to its end of use, that I can replace that cylinder or I can replace that valve before I have a failure, and now I've got unplanned downtime on my machine.
What's AVENTICS doing from a technology standpoint to help on the predictive maintenance?
The internet, the IoT or Internet of Things they've got a product that they can put into their valve manifolds that actually count cycle rates, and I can send that to the cloud via again a router built into the valve manifold, so I can actually count cycle rates over time, and then as that gets to an end of life cycle, I can start doing preventative maintenance before I have machine failure.
Okay. Are machine builders, and we're running out of time, but do they incorporate some of these new predictive maintenance features into their machine control?
They're being asked to do that over time. 5 years ago, no. As we have moved through that 5 years, they're being asked to do that a lot more than they used to be. So we'd like to be on the cutting edge of having something to offer. So when they get asked for that more efficient machine, if you will, we've got product that can step in and fill that void and help them out with that.
So because of IoT, in 5 years from now, the machine may tell us that, hey, you need to replace a valve.
Very much so. That's exactly where we're going.
Bill, very interesting. I appreciate your time. That's all the time we have now. Thank you for joining us.
Thanks, Tim.
You bet.